Oh, that's not the right one. It's actually the second one. That's the Udacity scholarship. But it is the right Women Tech Maker collaborating with Udacity. So if you go to Women Tech Makers here, and this will tell you what Women Tech Makers is. It's Google's Women Tech Makers program. It basically provides visibility, community, and resources for women in technology. And then if you click on apply to join, basically you will receive all the newsletter, etc. There are lots of good tips about how to learn coding, interview, or networking, just all kinds of interesting information. So now we're going to get back to the talk. So the first talk is going to be by Rachel Tatman from Kaggle, Why Natural Language Processing Needs Sociolinguistics. And please welcome Rachel. Maybe do the present? That would be great. Thank you. Okay. Thank you.
Great. I am Dr. Rachel Tatman. My doctorate's still fairly newly minted, so I'm trying to get it out there, get used to saying it.
Thank you. Thank you.
So quick show of hands, who here has ever worked with language data in any capacity? Text, speech, video of sign. Okay, most people. And who here has ever studied sociolinguistics in any capacity? Yeah, 2 people. Okay. So next time somebody asks you that, you're going to be able to say, yes, I know a little bit about sociolinguistics, and perhaps you'll be interested in learning more. So the core idea of sociolinguistics is that all language use contains social variation, and it's not random, it's systematic, it's predictable, and as a language user, you know this instinctively, right? When you hear someone's voice for the first time, you know something about them as a person that they didn't necessarily tell you with their words. You might have a guess about their gender, where they are from in the country, their socioeconomic status, their age, even over the phone. There's some research that suggests that in as little as 200 milliseconds of speech, you are beginning to make social judgments about people. And this applies to text as well. And the one question that I often get when I start talking about this is, what is it that's actually important? What social factors are really robustly evinced in language production? So at least in the United States, I'm going to focus on the United States today, but this is true of any large community. It's certainly true of China. It's true of Arabic-speaking communities in the Middle East. All languages have this variation, but I'm going to focus on the social situation of America because that's what I'm familiar with. So some things that matter in America are regional origin. So I'm going to focus on where in the US you're from, but also which country you're from, which general geographic area. Your age is important. Your socioeconomic status or social class, your race or ethnicity. And these are just sort of the main factors that I think are really important and relevant right now, but there's many others. So whether you're from a rural or an urban background, your gender, there's many things that affect language production, again, in very systematic, structured ways that we know a lot about. So let's start off with regional origin. Has anyone seen a map like this before? Maybe some people? Yeah. So there was a dialect quiz that went up on the New York Times website last year. And despite going up on December 24th, they became the single most visited story on their website. People love it. These are the major dialectal areas of the United States. My apologies if you're looking at the other screen. So the South, the Midlands, and the North, then the Rockies and the West. And each dialect region is associated with a number of features at different levels of the grammar. So that's everything from speech sounds to what words you might use, to what syntactic structures you might use, to when you think it's appropriate for you to jump into a conversation and how that turn-taking or behavior is organized. Some examples, it's relatively common in the North, especially North Central, to see things like the car needs washed. That's a syntactic structure that's perfectly fine there. And if you're not from there, it probably sounds a little bit weird. Some phonological factors, so specifically in the Pacific Northwest, we have something called the pre-vehicular merger. So that's where something like bag is said like bag, and bag is sort of said like bag. So I ate a bagel, or I ate a bagel, which is the same thing, someone could hear. Some of you might have heard of these. In the South, the sound oi is said ah. So instead of Sawyer, saya, instead of oil, ah. And these are systematic differences that are well documented and affect pretty much everyone who's in the region. And if you're from the West, which tends to be considered at this point the standard, you may not notice some of your features that you have them. All right, age, another thing that we know is important for your language production. And I should say I'm focusing on production because that's what's important here, but these also affect perception as well. So in general, over the course of your lifespan, as a very young person and a very old person, you will use more stigmatized features. So these are regional features like the bagel thing I was talking about that other people will notice and comment on. And in your sort of working years, we'll tend to use less of those features when you're in what we call the sociolinguistic marketplace, which just means you want a job and you want to sound sort of like professional and boring, if you will. Another thing that I don't have on the slide here, but is another factor, is that languages change over time. And younger speakers tend to use newer forms more. So something that got a lot of bad press was like as a quotative. So I was like, man, those people who don't like, which is language change that's ongoing. And younger speakers tend to do it more because it's coming into the language. And older speakers tend to do it less because they weren't alive when it started getting really popular. We also know that socioeconomic status really affects your language use. So this is one of the, well, it's impossible for y'all to see. You might have learned something about where I'm from. So this is one of the most famous studies in sociolinguistics. William Labov, who is a sociolinguist at Penn, went to a number of department stores in New York City and asked people where something was when he knew it was on the 4th floor. And in standard American English or general American English, that's floor with two sounds. And in New York English, that's 4th floor. And he found that the more expensive, not supermarkets, department stores had fewer people who used the New York form, so more 4th floor, less 4th floor, and the less expensive department stores sort of associated with a working class background had more 4th floor and less 4th floor. And this, again, I'm talking about phonology because that's sort of my background, but this is reflected at every level of the grammar, from word choice to syntax. We also know that race and ethnicity is really important. There are a lot of language varieties associated with a specific racial or ethnic background in the United States. Two of the really big ones are African American English and Chicano English, but there's also varieties associated with not African American communities, Native American communities, different Asian American communities. And these have systematic structural differences from general American English. So this is a kind of hard to read chart of the tense structural systems of standard American English and African American English. So tense is when in time something has happened, and aspect is the manner that's happening. So tense is past to future, aspect is it happened, it began in the past, and it's continuing to the present, or it has happened at multiple times in the past, but hasn't continued, things like that. And in standard American English, you have 3 aspects. And in African American English, they have 5. So it's a much richer aspectual system. And if you're trying to do something like narrative generation, and you're trying to sort of extract a timeline from a body of text, and you're not accounting for the ritual aspectual system, you will get it wrong. So why does this matter for NLP? There's social variation. We know that it's there. We know that it's systematic, that it's predictable. We have decades of research on this. And it turns out that when you don't account for that, and when you only include some language varieties, you end up with differential results. So people from different social groups have a different ability to use NLP. And this is also true for speech. So Lang ID is a general task of identifying what language a string of text is in. And Brendan and Lynn did some really good work, and they've replicated these results several times with different language ID identifiers, that
African American English is reliably less likely to be identified as English than Standard American English. In particular, it tends to be misidentified as Dutch because the sort of intensifier particle AF is also a common sort of preposition in Dutch. So if the language identifier hasn't been trained on English language data that it knows is English, it has AF in it, and it sees AF and knows that that's common in Dutch, it's going to automatically think that that's Dutch. Part of speech taggers, and this is an algorithm to identify whether a word is a noun, a verb, an adjective, a determiner, which then gets fed into parsers, are less good, again, at African American English, but also tend to be better on speech produced by older speakers. And this is because they tend to be trained on data that's a little bit older. So the Wall Street Journal corpus is one that tends to get used a lot. And that was produced a while ago. So what's the fix? We know that there's variation. We know that it's affecting outcomes. There isn't one simple fix, and I wish I could tell you there is. I think the first step is absolutely awareness, but there's also a lot of current approaches that people are exploring. So one thing is demographically balancing training data. So making sure that all language varieties that you might encounter are actually represented in the training data. So in the United States, that means getting training data from different social groups, from different socioeconomic statuses, from different regions, and making sure that there's a lot of variety and diversity in your language data. Mozilla is currently working on a project for this for voice. Also, incorporating other sources of information in addition to just the language. So a large body of work has looked at geotagging, especially for tweets, or GPS information for speech identification. And also generating models of variation. So a lot of what I've talked about previously has been based on sociolinguistic fieldwork, which is a really good tradition. It's very slow and very expensive and very time consuming and takes a lot of validation. And if you can automatically generate a model of the variation in some language, that saves you a lot of legwork. So John and Jacob are working on some really interesting work on developing non-parametric models of language variation to sort of identify what these sociolinguistically relevant groupings might be. I really recommend all three of these papers are from the workshop on noisy user-generated text at EMNLP that just happened earlier in September. So this is very, very recent work. So I just want to leave you with one final thought, and that is language is complex. If language were simple, no one would get a PhD in it. And there's no one single simple solution for dealing with sociolinguistic variation. So you do need to be aware of it if you're working with language data in any capacity. Thanks so much. And Martha, do we have time for a couple questions? Yes. All right, a couple questions. You can also ask me questions on Twitter. My tag that you can't see because there's a box over it is RCTATMAN. Anna?
What about variations in kids' language?
Yeah, so just to clarify, so the question was, what about variation in tone as well? Do you mean tone like lexical tone, like Mandarin has, or tone like happy or sad?
Yeah, well, we were doing our apps and we found that, you know, the kids but they don't think it. Why is that? And how does that
Interesting.
For that,
yeah, kids are hard. So my background is more in speech.
Understand my kids.
In general, we know that children are, especially very young children, are more attracted to high, fast sounds. So it could just be sort of like that's what's catching their attention. I've talked to an acquisitionist. And then, yeah, absolutely. So the question, yeah, I was just going to. The question was, is there work on identifying regional origin just by accent and then accent, not accident, and then using that to adopt models? Yes, absolutely. So in automatic speech recognition, there's a major task dialect adaptation. And one of the ways that that's being done is similar to what you're saying, usually taking a number of words that are really distinctive, so like the bagel bagel thing that I was saying, and then using that to pick one of a number of pre-trained models to use for a specific person. There's also been quite a bit of work on sort of getting rid of that and just adopting the model so that you have lower error rates over time, which is very computationally intensive. But if you've ever used Dragon Naturally Speaking, they do the second thing. They sort of adapt to you as a speaker. Yeah. So yes, it's hard. It's hard. It's especially hard with educated speakers. Yeah. Mm-hmm. Yes. Gender is really complex, which is, I thought about including it, but it did not have a place in the 15-minute talk. So let me give you the super, super condensed version. There's lots of differences between men and women. There has been less work on other genders. Some of the bigger differences are that women tend to use more politeness markers in general. Women tend to back channel more, so say things like and not use that for agreement as often. Also, when a language change is coming into the language, if it's something that people are aware of, so like women tend to use it less. If it's something that people aren't aware of, like, let me come up with a real good example. Sorry, this is hard to come up with an example for. So if there's something that people aren't noticing, then women tend to lead the change. So women's language changes faster when, this is called the gender paradox. So women's language changes faster when they're not aware of whatever the change is, but it changes slower when they are. Yeah. Oh, people are aware of that. Like anything y'all are going to ask me a question about, people are going to be aware of. Yeah, absolutely. And there's also no difference in gender there, actually, as far as we can tell. Yeah. Yeah, that's a really good question. So sorry. So the question is, what is the effect of speech to text on language variation? It's hard to say. We're pretty early in it. People who speak varieties that are less well recognized by speech to text tend to know that their variety isn't considered as good in some way. So I'm from the South and I don't necessarily really sound like it. And part of that is because, it's an intentional choice because people from the South aren't considered as smart. For whatever reason, there's nothing linguistic about Southern speech that is better or worse than any other variety. So people who are in that position generally already have pretty fine-grained control over sounding more or less standard in different environments. And it might just be that speech to text is one of those environments where they're like, oh, I should be standard here. But it's definitely an access issue. Definitely. I've done some recent work that shows that speech to text, not speech to text, speech to text, ASR, works better for Caucasian speakers than any other group. I saw a hand over here. Yeah. Mm. Mm-hmm.
We already know
I don't think there's any difference in language acquisition between genders. I've seen no research on that. No, I've seen no difference in that. People tend to be pretty good about maybe gender's a thing. Oh, it's not. I would be shocked. Yeah. I don't want to say that there's no evidence, but I have seen no evidence that there is a difference between genders in terms of acquisition. Yeah, that's a good question. So the question was, how often is there a new dialect? So I showed you sort of the least, what's the word for it? Contentious? The least contentious map. Lines get redrawn all the time. So the way that those lines are drawn, I'm gonna go back. I'm assuming you're just talking about regional dialect. Location in general. Yeah, so people will start speaking like other people as soon as they feel like there's a reason for them to be like that group and not like a different group, right? So it's a reflection of your social identification with a group of people, and you just reflect that automatically in your language use. And there's been some work on this in the lab, even just like giving people a fake test that's completely rigged and saying, okay, you guys got the square on the test, and you guys got the star on the test, and you're square people and you're star people. And the groups will begin to converge within themselves and diverge from others. So as soon as there's any sort of social division that has an identity attached to it, then you'll start to see language like movement into the community and away from the other communities. I'm just gonna take one more, because I know that this is something I can talk about all night and I don't wanna eat in other people's time. Yeah. Yeah, so the question was, is there any evidence that migration and globalization is changing language and affecting how they merge? Yes. So there's a whole field of study on what's called global English in particular. So this is the variety of English that is spoken by non-native speakers with each other as a lingua franca. And there's been a lot of work on that. And that has some, again, systematic differences from the language of native speakers. And in global English situations, being a native English speaker is actually a disadvantage because you're not familiar with those sort of ways that those speech patterns work. Oftentimes people ask me if regional dialects are disappearing. No, they're not. They sort of peter out once you, so if you think of going up social class, which is perhaps a loaded way of thinking about it, once you sort of get to college education and college education that doesn't have a regional identity associated with it, so you're not going to an ag college and you have that strong, like, I don't know, regional identity associated with that college. Once you're sort of a mobile urban professional, that is a specific speech community that doesn't necessarily have the same linguistic variation that we see with less mobile people in general. I hope that answered your question. Yeah. And again, feel free to hit me up on Twitter. I'm happy to talk about this all day.
Thank you, Rachel, for the talk. And next up is What's New in NIST Digital Identity Guidelines by Sarah Squire from Engage Identity. And I will switch the slides over. Clicker. Please welcome Sarah.
So my name is Sarah Squire. I work in a niche field of information security called identity and access management. I work for a company called Engage Identity. It's a company I started a little over 2 years ago. It's called Engage Identity because I have an unhealthy obsession with Captain Picard, the best captain. And one of the clients that I have at my company is the National Institute for Standards and Technology. So we've spent the last year rewriting the digital guidelines for federal agencies around identity and access management. I was one of 14 co-authors on this document. It's a huge, very long document, but it was a lot of fun to work on. It was just released in June of last year at the Cloud Identity Summit. So it is now in effect for federal agencies, and I'm going to tell you what's in it. So we're going to start with a little historical detour, but this does have to do with information security, so stick with me here. We'll get there eventually. So in 2009, there was a contested election in Iran. This was 5 months after the inauguration of Barack Obama. The incumbent president, Mahmoud Ahmadinejad, was very unpopular. Another candidate was favored to win. His name was Musavi, and the color of his campaign was the color green. When the election occurred, Ahmadinejad won almost 2/3 of the popular vote. The youth in Tehran immediately flooded the streets. There was a huge amount of rioting, some peaceful, some not. There was a lot of police brutality. Iranian media was banned from covering the event. IP addresses of social networking sites were blocked so that eyewitnesses could not post photos or videos to social media. But people outside Iran set up proxies so that people inside could report the eyewitness news. I'll give you a minute to read these. So Persian Kiwi is a pseudonymous identity. That is obviously not that person's real name. It's important for these people to have the ability to do pseudonymous authentication. And what I mean by authentication is that they can log in. They can securely prove that they are the same person we saw last time without us knowing who they are. So these people would not have used Facebook, which at the time required and expected people to use their real names. So I'm going to talk to you a little bit about the old NIST guidelines that before we rewrote them, they conflated people's identity with their level of security. So we'll talk about how that worked and why we changed it. So we're going to go over 4 things. We'll talk about what authentication is and why we're measuring it. Then we'll talk about the old levels of assurance, which is how security worked before we rewrote it, the new guidelines, and then we'll go over some of the stuff that's been making headlines lately. You might have heard about it on NPR. We have new password guidance and new multi-factor authentication guidance. So we'll go over those last. So what is authentication? Why are we measuring it? So NIST was founded in 1901, and it was founded to measure things. So they handled meters and kilograms and pounds and gallons, and they did this because they are under the Department of Commerce. So we want to regulate how much milk is in a gallon so that the free market can decide which milk is the best, and consumers can compare things on a fair basis. So if each of you in this room opened a winery and started bottling wine, it would be very difficult for me as a consumer to figure out what I'm buying if all your bottles are different shapes and sizes, right? If we create a standard, then it makes it easier for consumers to compare for the best brands to succeed. So it's the 21st century. We are now measuring authentication solutions. How do we do that? So I did a project a couple of years ago. Do we have any XKCD fans in the room? Yeah, my people. So Randall Munroe, who writes a webcomic called XKCD, also wrote a book called Thing Explainer. And it explains complicated objects like rockets and refrigerators using only the 1,000 most common words in the English language. So I went to see Randall Munroe at Town Hall in Seattle with an identity colleague of mine. We were having beers after the show, and we said, what if we did this with identity? What if we used the 1,000 most common words in the English language to try to explain what we're talking about when we talk about our field? So we did that. The talk is up on YouTube. It's a lot of fun. It's called Identity in 1,000 Words because 1,000 is not actually in the 1,000 most common words in the English language. So this is what we came up for authentication. Making sure that a person or thing is the same person or thing you saw last time, which is different from them being who they say they are. And that parenthetical is really important. That parenthetical is what allows for political dissidents, for whistleblowers, for people who need anonymity and high security. So the way that things used to be with federal agencies and security was that we had something called levels of assurance. And levels of assurance were created to deal with different threat models. So we were looking at 6 categories of attackers that might not be the person we think is at the end of the wire. So the dog represents unintentional account compromise, right? So your cat walks on your keyboard, your kid posts to your Facebook page, right? Maybe that's not so important, but if we're talking about diplomatic cables, right, maybe it is. The next one is a snooping girlfriend. So this is someone who might have access to your devices, but maybe not your passwords, maybe old passwords, but not new passwords. Next to her, we have bots. So bots don't have access to your devices, but they're very good at brute forcing passwords. They're probably after spamming more than anything else. On the lower left there, we have people who are after cash. So these are generally identity thieves or people who want ransomware. Next to that, we have state actors. So these people might not have access to your physical devices, but they do have a lot of resources. So these are people who might forge access tokens, who might be able to find zero-day bugs, who just have a huge amount of ability to break our protocols in general. And then to the right of that, we have hacktivists who generally have a political motive. They might target very specific individual people. We might be looking at spear phishing attacks like that. So the question when we talk about levels of assurance is how sure are we that the person at the end of the wire is Sarah Squire and not one of these 6 imposters? So there were 4 levels of assurance: little or no confidence, some confidence, high confidence, very high confidence. So let's say we're dealing with our Iranian eyewitnesses. We want to have very high confidence that the person we're talking to is who they say they are, right? We want to make sure that this isn't the Iranian government coming in and either deleting the history of the account, which is the only historical record we have of that event, or posting false information saying, hey, everything's fine here, right? So we want to have very high confidence that the person we're seeing is the same person we saw last time. So to get a rating of level of assurance 4, you have to have strong cryptographic authentication. So what that means is that you need two kinds of devices. You need 2-factor authentication. So when I talk about factors, what I mean is something you know, like a password, something you have, like a phone, or something you are, like a fingerprint. We want to have any 2 of those categories, or in my case, something you'll forget, something you'll lose, and something you'll get a paper cut on. We want to make sure we have that. And then we want strong man-in-the-middle resistance. We'll talk a little more about what that means later. No bearer tokens. So bearer tokens are the online equivalent of writing your name on a napkin and throwing it across the room. They're like the letters of transit in Casablanca. So whoever is holding it, that's who it refers to. It's very low security. We don't use it at level 4. And then finally, the account owner has physically appeared and a government-issued photo identification document has been verified by the relevant agency, right? So this one is the problem. This is where we run into a problem where we have to say all political dissidents, anyone who wants to be anonymous or pseudonymous, has to be level of assurance 1. So we wanted to rewrite these. We wanted to take into account some of these edge use cases. So we wrote this new document. This is the first NIST document to be written online in public on GitHub. So our team managed to convince the powers that be at NIST that our old process, which was we go in a back room and write a standard, and then we send it out to the world. You guys send us email. Some poor soul in the NIST basement correlates all the email, sends it back to us. We rewrite it, issue another draft. We said, this is stupid. We have GitHub now. People should send us pull requests. And people did. People forked the project. They sent us pull requests, anything from 1-word typos to paragraphs of text by industry experts. So it was a really great process. People brought up issues online. We were able to discuss them publicly. And you can see the whole history of how the document was edited in real time. So it was a really great process for us. This GitHub repository does require 2-factor authentication. When I log in with 2-factor authentication, I use YubiKeys. I keep mine on my earrings. These are YubiKey Nano 4s. So I have to stick these in my USB drive anytime I want to log into GitHub. So if you wanted to maliciously edit this document using my account, you would have to steal my earrings. So these are the new guidelines. We have, instead of having 1 scale, we have 3 scales. So we have identity assurance level, how sure that you are a real person connected to a real legal entity. Authenticator assurance level, so whether you're using 1-factor or 2-factor authentication, and then federation assurance level, which is how secure that assertion was when it went over the wire. So identity assertion level 1 is pseudonymous. So this is what we were looking for, right? We want a way to say that you can be a pseudonymous and have high security. Level 2 is remote or in-person identity proofing. And proofing just means that someone checked your ID. Someone knows that you're a legal entity. And then level 3 is in-person identity proofing with biometric collection. But the biometric collection isn't for the purpose of authentication. So we're not taking your fingerprint because we want to use it later when you log in. We're taking it for the purpose of what we call non-repudiation. Non-repudiation means that you can't come back later and say, that wasn't me who created that account. That was someone pretending to be me who came in with my photo ID. Because we have your fingerprint on file, or we have your iris scan, or we have something else to say that the person who came in and created this account was actually you. You can't repudiate that. For authenticator assurance levels, level 1 is single factor. So this is either a password or a device or a fingerprint, something like that. Level 2 is 2-factor authentication. So any 2 of those categories, something you know, something you have, something you are. And then level 3 is 2-factor authentication with a cryptographic device and verifier impersonation resistance. So cryptographic device means that you're not just getting a one-time password to your phone that you're typing in or to a device that you're typing in. It means that there's actually a device that has a private key on it and that it is being issued a challenge, it's signing that with its private key and sending it back, which is more secure than a one-time password, which could be phished. And verifier impersonation resistance means that when that challenge is signed and sent back, it is tied to either the TLS channel that it's going over or the host name that it's being sent to, meaning that if there is a man in the middle, you can tell because they're on a different TLS channel or they're using a different host name. You can do this for OAuth as well. So OAuth access tokens can be bound to a TLS channel. So this is what I was talking about before with bearer tokens. So the IETF mailing list for binding bearer tokens to the TLS channel is actually called unbearable. There are like 2 people with a sense of humor in the IETF. That's the Internet Engineering Task Force. They set a bunch of internet. You've ever heard of like SMTP or TCP/IP? Yeah, a couple of them are funny. It's true. I've had them. Federation assurance levels. So level 1 is a signed bearer assertion. So that means that it is a bearer assertion. It doesn't have a high level of security, but it was at least signed by the person who issued it so that we can check that the person who issued it was valid. Level 2 is signed and encrypted. So that means that whoever it was made for, if it was made for Wells Fargo, it can't be used at Chase because Chase doesn't have the key to unencrypt it. And then level 3 is signed and encrypted holder of key assertion. This was somewhat controversial to put in the standard. Holder of key assertion is not available in off-the-shelf software right now. So what holder of key means is that if you're using federated login, so if you are, say, logging into an application and it says, hey, use your Facebook account to log in or use your Google account to log in. What holder of key means is that after you authenticate with Google or Facebook and come back to the application you were using, Google and Facebook tell the application, this person has some sort of key, they have possession of a private key. Here's their public key. You should make them sign something and make sure that it's really them. So what we call the relying party has to do some identity checking as well. And we wanted to put this into the standard because it's been 10 years since the standard was rewritten. It may be 10 years before it's rewritten again. So we wanted to make sure that we captured the fact that there is a more secure way to do federated authentication than exists right now in off-the-shelf software. So to give you an example, if we were dealing with the Secretary of State, she would be identity assurance level 3, right? We have in-person proofed her. Assurance level 3, because she's got a government issued PIV card, so that has a cryptographic protocol on it where she can sign challenges. And she would be Federation assurance level, presumably 2, because level 3 isn't available in off-the-shelf software right now. So this is basically how, rather than saying level assurance 1, this is how we now specify the security that's behind any given authentication transaction. So let's talk about some of the stuff that's been making headlines. Multi-factor authentication guidance. So knowledge-based authentication, what we call KBA, is banned. You're going to cheer when I tell you what this is. Are you ready? Do you have your cheering voice ready? This is secret questions. Yay! We have banned secret questions. They're terrible security. So this is how Sarah Palin's Twitter account got hacked, right? This is why people don't tell each other their first pet's names, right? Like, it's terrible security, right? Most of it's public information. It's very easy to find. It's also really bad usability. So I helped the University of Washington get rid of their knowledge-based authentication process. They had data going back 10 years saying that 60% of people don't get their KBA questions right on the first try. So users hate it, security people hate it. It was kind of a win-win all around there. It's completely banned from federal agencies. And then one-time password over SMS is now restricted. So SMS stands for short messaging service, not secure messaging service. The publicly switched telephone network has huge vulnerabilities. We know that. SMS can be sniffed with off-the-shelf hardware and software. And it's easy to socially engineer a phone number or port a device, get a device replacement, right? As long as you can walk into a Best Buy and any 15-year-old can say, oh, here's your new device, I'll port your phone number over, and indeed get a commission for doing so. As long as I can walk in and say, hey, I'm Madeline Albright, I want a Pixel, move my phone number over, right? That's not good security. So we're saying that that's now restricted. You can use it, but you have to have a really good reason for doing so. Otherwise, it just counts as one factor, not a second factor, so it wouldn't count as something you have. So password policy guidance has completely flipped on its head. In the old document, we told people that they should require special characters and numbers in passwords and uppercase and lowercase. And while that is true, that does increase what we call the entropy, the complexity of the password. It makes it harder to crack. When you require those things, though, you're actually making the space that an attacker has to look at smaller. So they know there's a number in there somewhere. They know there's a special character in there somewhere. So it actually makes it easier for them to guess the password than it would be if you had no requirements at all. So we took away that guidance. We were saying you should not require any special characters whatsoever. And you should never force users to rotate their passwords. Forcing rotation of passwords, so saying you have to reset your password every 60 days, every 90 days, things like that, tends to make people have patterns, right? So a friend of mine worked for a hedge fund. She said, yeah, everybody on the floor had to change their password once a quarter. So everybody's password was fall 2016, exclamation point, spring 2016, exclamation point, winter 2017, exclamation point, like, right? And when you force people to rotate their passwords, they will intentionally make things that are easy to guess because they're not going to be able to remember a long, complex password once a quarter. It's ridiculous. So things we are recommending: allow ridiculously long passwords. If you are storing passwords in a database rather than hashing them, you have much larger problems. So yes, allow people to have passwords that are as long as they feel like having. Sure, there's some theoretical limit where hashing becomes very onerous, but that limit is very long. Accept spaces and special characters. So like I said before, we want to accept them, but not require them. And spaces just help people remember passwords better. If you can put a space in it, you can put words in it, you can help yourself remember what the password is. And then one new requirement that we have is comparing to a breach corpus. So we know that many username account pairs have been leaked online, on the dark web, on the open web. We know what they are. If you are trying to reuse a password that we know that attackers, that identity thieves already have in their possession, you should not be able to create the account with that password or change your password to a password that has been breached. So those are our guidelines. Hope you all enjoyed that. Thank you very much. Are there any questions? Yeah. So the question is, how do we get companies to value security? That's a great question. And I think until stock prices start reflecting it, we won't. It's just a fact that as long as they can continue to make money and continue to be insecure, not a lot is going to change. There are new regulations coming out in the EU called General Data Protection Regulation that go a long way. And fortunately for us, they don't just apply to EU citizens, they apply to EU residents, which means that a lot of American companies now have to comply with those regulations. So those regulations include things like you have to report a breach within 72 hours, unlike the Equifax breach, which was reported in 2 months. Yeah. So we're going to be seeing a lot more American companies coming into compliance with that. That goes into effect May 2018. So good things are coming, but the motivation's entirely economic for them. Until we see that, it's regulation and it's economics. Yes. So the question is whether offices in the EU have to comply, and actually it has, the General Data Protection Regulation has nothing to do with where the company is located. It has to do with where their, I want to say their customers, but it actually applies to anywhere you have an account. So you don't even have to be a customer there if you have a free account, any EU resident. So the Seattle Google office will have to comply with EU regulations if they are dealing with any EU resident. And the fact is, if someone is creating an account online, you can't know whether they're an EU resident. So you better have that account be compliant. And the teeth behind that regulation is that the EU can then fine any companies that are out of compliance up to 4% of their global revenue. So it is a huge, huge deal. We could and will hopefully see some very large fines for people doing things like what Equifax did. Yeah.
know, media, how we can create a strong, process so we don't get hacked.
Yeah, how do you create a strong process to not get hacked? I recommend that you use a password manager. I use LastPass. I have it on my phone. I have it on my computer. It enters all my passwords for me, which is great. I don't have to remember any of them. And anytime I need to create a password, it will create a very long, very complex password for me that I don't have to remember, and it will store it. So I recommend that. I recommend turning on two-factor authentication anywhere you can. Most places are going to have a code sent to your phone, which, as we talked about, is not the most secure, but it's much better than just being able to crack a password. So those are the two main pieces of advice that I give to people. And also, since the Equifax breach, I've been telling people also freeze your credit. So go to all 3 credit agencies, make sure to freeze your credit to make it more complicated if you want to open a new credit card or a new line of credit. And then also, this breach contained enough information for someone to be able to file your tax return for you, which is how a lot of online fraud, identity theft, like if you are an identity thief, that's how you make money off of it. You file a false tax return, and you have the money sent to your bank account rather than the bank account of the person the tax return is about. So you can create a PIN with the IRS so that you cannot file your tax return without that PIN. So I would recommend setting that up before January. Yeah. That's a great question. If something like Equifax can be hacked, can a password manager be hacked? Yes, it can. And it's not a great solution. And it is a honeypot, what we call a honeypot, right? It's a lot of valuable data on a lot of people. But it's the best solution we have right now. I wish there were something better, but there really isn't. So some people are uncomfortable using a password manager. It is possible to have a password manager that is installed on your local computer, so it's not stored in the cloud. If you're really concerned about password managers getting hacked, that's what I would say. Someone would have to hack your local computer in order to get at your passwords. So that's an option if you're paranoid about that. Yeah. Yeah, so what's going to happen with biometric authentication? Yeah, it's a really exciting field, but there's not a lot of research on it yet, and we're moving very quickly into adopting it into very common devices without doing a lot of research. So how easy is it to spoof a fingerprint if you have a lot of resources at your disposal? We don't know that. And how easy is it to spoof a face if you have a lot of resources at your disposal? We don't know that either. So a lot of technology is being adopted before research is done on security. So I'm hesitantly optimistic. The answer to that question. And I'll take one more, and then we should move on to the next speaker. Yeah. What steps do we need to take to make sure that we're more careful in what we adopt? So that's a great question. There is not a lot of information security research being done at universities. I would love to see more funding for that. Unfortunately, there are not a lot of companies that have an interest in just generally making the internet more secure. There's no one company that makes money off of that, right? It's not like pharmaceuticals where you can just fund drug research. Funding security research is much more difficult. It's much more complicated. We don't really know how to do it. That's how we ended up with Heartbleed. Like, there are vulnerabilities in very commonly used web protocols, and we haven't found them because we haven't funded research for them. So that's something we as a community need to figure out how to do and how to do properly. So thanks, everybody.
Thank you, Sarah. I never thought security could be this fun. That was a great talk. there's a full screen button. Is this one? Yeah. Okay. So now I'd like to share with you about how to get started with machine learning. How many of you are interested with learning AI and machine learning? Almost everybody. Great. I will try to keep my talk really short, under 5 minutes. So I'm an Android developer, and I've been studying AI and machine learning. So I want to share with you some tips and tricks from my own learning experience. First is, my first tip is start out easy and simple. So I've included some links here for you to watch. There are short videos you can watch. For example, the machine learning recipes by Josh Gordon. He is the developer advocate for TensorFlow at Google. Each of his short 5 to 10 minute mini video will teach you a machine learning concept. And then the Cloud AI Adventure series by Yufei Guo, also a developer advocate at Google. But his talks have the machine learning basics, but also have something to do with the cloud. And then I recommend you watch Suraj Ravel's videos. Have you heard about, anybody heard about Suraj? One person. Okay, so I've included links here for you. You can check it out later. His videos are funny and entertaining, and he speaks very fast. So most likely you'll have to play his video at a much slower speed to catch whatever he's talking about. Funny, entertaining, but also educational about machine learning and AI. And some of his videos are short, but some of them are long live demo coding as well. So I recommend you watch that. And then another way of starting out easy is to, how many of you are app developers here? Quite a few of you, and I'm an Android developer. So you can start making apps by just REST API calls to machine learning services. For example, Google's Vision API. And a lot of companies also provide these APIs, vision, speed, natural language processing, etc. And you don't need to have any machine learning knowledge. You just do that REST API call and you get a JSON response back, but you have to parse that response. But that will give you some idea of, okay, here's the input. You know, you send off some data, image, or text, and then here's the output of that machine learning algorithm, the output that you get back and you parse the data, right? It will give you some ideas. And then you can also work through some collabs. For example, one of the earliest TensorFlow collabs is called TensorFlow for Poets. How many of you heard about it or gone through that one? So one person. So I will include the links here later on in my slide. It's basically, the Docker container already contains the image and the data, the model, and everything. All you do is run a couple of the Python scripts, and you do the training of the last few layers of the model, and then you can recognize some flowers. So not in-depth machine learning knowledge, but just give you a feel of what it is doing, right? And before you get started with machine learning or while you're studying, I recommend you just learn some prerequisites. Math, if you're good with math, that's great. You know, refresh on linear algebra. Also learn Python and statistics. So last year I took this linear algebra refresher course from Udacity, which was great, a couple weeks, and it helped me review linear algebra at the same time, also pick up how to program in Python. And then the third tip I have is to try to understand the concepts under the hood. You know, earlier I said, okay, start out easy and simple, watch some videos, just get some high-level concepts, right? But once you get serious and you start learning, it's best to just do the programming and understand using Python or NumPy instead of using a more high-level, say, a framework, right? That way you actually have a good understanding under the hood, or use some, you know, you go through the hard way or the challenge way, and later on you can use the easier way using a framework or a library or Keras. Okay. So I promise I will keep my talk under 5 minutes, so I'm gonna zip through really quick. 10 years ago, you to learn machine learning or AI, you need to go to a university to get a PhD degree. But today, you don't have to. There are tons of online resources and books, etc. Now is the best time to get started learning. So Udacity, Coursera, Stanford all have the machine learning classes. And Udacity has the intro to machine learning class. And recently, I think about February, they started this deep learning nano degree. And it has 5 parts. It has some of the Siraj's videos in there as well. But the intro to machine learning has been around for a while. I suspect it's probably the beginning of Udacity has that intro to machine learning. There's also machine learning nano degree as well, and then a deep learning course, not the nano degree itself. On Coursera, there's also an intro to machine learning by Andrew N. And that was probably the first class as well of Coursera. It's been around for a while. There is the deep learning specialization recently started in August 2017 this year. I highly recommend that one for learning deep learning. And then the machine learning by UW, which has 4 or 5 courses. And the very first class, it's a very good intro to machine learning basics, but they're easy to pick up and get started. And then the Stanford courses on image and visual recognition. And then the last one I will include the link as well. It's talking about TensorFlow. And Cadence is more for like art and music using machine learning and TensorFlow. So here are some of the books that I recommend. There are a lot of books these days coming up as well. The Hands-on Machine Learning with Scikit-Learn and TensorFlow. The author, I think he used to work on the YouTube team at Google, so he's very familiar with TensorFlow. And the first part of the book talks about machine learning, and then the second part is deep learning with TensorFlow. So out of curiosity, does everybody know the difference between AI, machine learning, and deep learning? Sort of, yeah. So let me just quickly go through what the 3 things are. The AI, artificial intelligence is more of the big umbrella. And then machine learning is one way of enabling that AI. And then deep learning is a subset of machine learning and has become really popular in the recent years due to the large amount of data available as well as the advance in computing power. So if you take the deep learning course from Udacity or Coursera or somewhere else, people will claim that you don't need any prerequisite, maybe know a little bit Python, you're good to go. But my recommendation, as well as this book author's recommendation, you should learn a little bit of basics of machine learning, before you dive into deep learning. And then the second link is a free online book. Okay, there are more learning resources. I won't go through all of them. These are just some links to the blog. And then the last link is my blog. I wrote Get Started with Machine Learning. I tried to just include all the resources on books and blogs and videos. Anything that I come across, I would just compile it into my blog. Yeah, okay, great. That's it, my talk. And any questions for me? Just I hand over to Anna. Okay, so if no questions, I'm going to hand it over to Anna. Oh, one question? I have not heard about that. There's so many resources out there, but I think it's probably okay. Yeah, but I think it's probably okay because one of the things that I recommend, the machine learning one program by UW on Coursera, the first class, they use a proprietary software. I can't quite remember the name of it. But the good thing about it is you don't get overwhelmed with a lot of setup because it's quite complex when you need to set up with different things. You might get so overwhelmed, you get discouraged to even continue. Mm-hmm. Yeah. Okay. Great. Yeah. Another question?
Did I do
All right. I have not worked with PyTorch before, but I know there are other libraries out there like Cafe, etc. Right? How does it compare? I haven't done the investigation or analysis myself, but I've seen slides and other people's talks actually comparing all these different libraries in terms of performance and the features they cover and users, etc. But I can't speak to that off the top of my head. Okay. All right. So I'm going to, if you have more questions for me or the other speakers, come find us after the talk. Now I'm going to hand it over to Anna for the next talk. Let's see. We're going to switch the computer.
I already did. Yeah.
Oh, okay.
All switched. You're good, right? Okay.
Okay, great. So I just want to introduce Anna a bit. Anna was my teacher, and she's been a friend, and she was also helping out a lot organizing GDG, as an organizer. And she's also a great presenter, and now she's going to talk about hacking Gradle to deliver 126 APKs.
Thanks, Margaret. So other than all that, my day job, sort of my day job. I have 2 kids, so I don't know, maybe they count as a day job. Is I am founder and CTO of Infinut, and we build math applications for kids. I started about 6 years ago, and for a good period of that time, I was just building them on my own. And then 2 years ago, we got an NSF grant that we used to then build out the team. So at one point, we were 5 people, 2 developers, a graphic artist, audio engineer, and education curriculum designer and researcher. So we built the whole K-2 curriculum for that. And I'm going to demo that first, and then I'm going to come back into the talk, and I have a couple of questions for you guys too. So this was the new application that we built, and this is the kindergarten version. And there is a whole bunch of lessons in here for the kids to learn concepts step by step. And we focused much more on conceptual learning and not rote learning, which is very popular. Rote learning is what kids do in school right now. They don't do too much understanding of what it is they're learning. They just sort of memorize it. So how we do that is, let me actually show some of the little more advanced ones. Sometimes it's hard for people who are not in kindergarten to understand, why do I have to move objects to learn something? Because we've already internalized those concepts. So, but some of these you can understand. For example, like compose 10. This is actually becomes a pretty hard concept for kids to understand what composing a 10 means. So here, oh, I have sound muted, is it? Can I turn on sound or no, Yenti? Maybe not. Okay, so this actually speaks all the directions. And I was talking earlier when I was mentioning that when Rachel was talking about her linguistics talk, we actually tried a whole different variation of voices. We tried teachers, we tried adults, we tried voice artists, all this kind of stuff, and finally settled on kids. For kids app, kids voices work. Otherwise, they don't respond very well to that. So we had to do all our own recordings and all that. So that's why the audio engineer. But it tells them to put 7 and then 3 houses and then compose them into a 10. So now they can really visually understand what that means. And then they dance the end, and they get a little, fun animation at the end. So this is first grade. First grade had 40 lessons. Kindergarten had 30 lessons. Second grade had 50 lessons. So that's how we get to 120 in the 6. All right, I'm going to go into the presentation. So how many of you, this is all written in native Android. How many people have written something in Android before? Oh, some people. So you guys all know what APK is. Anybody, so who doesn't know what an APK is? Okay, some people, okay. So an APK is an Android app. Is one app is an APK. But like I said, I'm talking about 126 APKs, 126 apps. What did you do, Anna? You flooded the whole market. Not quite, but I'll explain. But each APK is essentially a package that gets installed onto the device, and it acts as it's what you launch. And anybody know what Gradle is? How many people here know Gradle? Okay, quite a few actually. So Gradle is the build system. How many of you have used some sort of a build system? A Make, Ant, Maven? A few. So this is Android's build system, which is used to build the APK. Right? So it does, it compiles everything, it puts it all together into that package, and then we can ship that package. And that package is called APK. So how do we get those 126 APKs? So that was the app I showed you. So we had 3 apps. Those are 3 apps I showed you: kindergarten, first grade, and second grade app. That's the first 3 APKs. Because we ship each grade separately. That's just to keep the size of the application small. Otherwise, it would just be way too large. And then for each of those, we ship a home version, which has student profile management and in-app. You can do in-app purchases. How many people done in-app purchases? Not too many. That's less than the people who said they don't know what Android is. Yeah. That's what's ailing the rest of the market. And then we have a version for schools, which integrates with Google Classroom. That's specific to that's specifically for use in schools, and it builds their class roster and provides them dashboards based on their classroom. And so for each one of these, we have a school version: kindergarten, school, first grade school, second grade school. So that's 6 APKs. And then for library, we did something completely different. We needed offline usage, and so we partnered with this company called Playaway Digital, and they came out with these tablets sometime back, but they're loading them with our content now. So this was a special licensing deal, and they wanted each of those lessons as a separate app, so they could preload them onto their tablets. And they get distributed across 12 tablets. Each tablet would have only 10 apps. That's their model, because it is for circulation in libraries. So libraries don't want too much data, too much playtime on there. They want to limit the playtime so that tablets actually come back. Otherwise, people would be like, oh no, you got a year's worth of stuff. I'm not bringing it back in a week. So, and they kind of understand the library market, so we actually went back and forth quite a while. It was 6 months. It's finally coming out next week. We started in Feb, so it should be finally in production next week. So that's where the 120 APKs comes from. those were individual lessons had to be built into separate APKs. So that's the 126 APKs. So we had to customize the build quite a bit to get to build those 126 APKs. I initially thought I might be able to do it by hand. And then I realized, oh no, what if we make a change and then I have to redo it? Okay, so I could have done it once maybe, but not without errors. So the first thing we used, these are the things that I'm going to talk about that we used within the build. Build flavors are something built into Android build, and they allow you to have slightly different variations of the same app and build them into different packages, different APKs, and publish them separately. A build config field allows you to pass data from a build to Android code, so then you can customize Android code based on what you're building. And custom build tasks was that 120 APKs, we had to extend the build. So product flavors. This is how you define the product flavors. So for us, we used kindergarten was one, first grade was another, second grade was another. And application ID, this is the ID that is associated with the APK, and it has to be unique. So we gave each one of them a unique ID. And then when we write our code, whatever is common between those three, we put that in main. And whatever is different between those three, they go into their individual folders. And that way, when it combines it, when it's running the kindergarten build, it'll go main and kindergarten, package those together, and so on. And the thing that flavors gives you that libs doesn't, if you're doing a library and you're including the library, you get everything from that library. But in flavors, what you can do is you can have different versions of the same class. For example, for kindergarten, this is the lessons class for kindergarten, but the first grade lessons are completely different. So this class is completely different. But there's a copy in kindergarten. There's a different lessons class in first grade and a different one in second grade. So that's how and then when it's packaged, it gets the right lessons for each one. Oh, so then it gets more complicated. It had to. It's going to keep getting complicated. We do dimensions of flavors, 2 different dimensions. So one is the grade, and then the other one is where you're using it, sort of market, which is school, home, or library. So now it will build kindergarten school, kindergarten home, kindergarten library, and so on, because those are 2 different dimensions. And we provide a suffix .school. So for kindergarten, the application ID will become kindergarten math.school, and then so on. Now the folders kind of explode a little. So you have the kindergarten special folder, then you have the home special folder, and then you have kindergarten home special folder, and all the variations of those. They kind of explode. So we couldn't do the 120 with this. That would have been a nightmare. 6 is just fairly manageable. So we were getting if your Gradle build has tasks already built in, and the task we run often is called assemble release, which basically runs all the builds and builds all the APKs, so then we can publish those. And then there's access by the library ones, because we didn't end up using those, because we needed the 120 across the 12 launchpads. So for that, we used a build config field. It's actually at the bottom here, the build config field. So what we needed to do was build each APK with a single lesson. So how we did that was, for the library version, we said, we'll give it the lesson, and it'll just launch into that lesson only, and it'll just ignore all the other lessons. That's how the code was written, but it needed to know which lesson to launch into. So that lesson was provided by the build. And that then got incorporated in the code in the top part where it says build config.lesson. That's actually the field coming from the Gradle, from the build file. It gets that data and it incorporates it. And it just directly launches into that lesson. But then we still had to invoke that build 120 times, which is the task at the bottom. And this task actually is generated inside a loop. So we didn't actually write 120 tasks separately. Gradle is based on the Groovy language. Anybody use Groovy? It's a superset of Java. It incorporates Java. It's slower than Java, so it's perfect for a build system. And it's also very dynamic. So what you're basically doing here with task APK $index is, and defining that task is we're creating a function on the fly inside the loop. So we're creating all these tasks, build tasks on the fly. So this will create APK 1 to 120, all of them. And then at the bottom we say release library depends on APK $index. So all those tasks will depend on release library. So all I have to do is go Gradle w release library, and it starts building the 120. It takes an hour, but I can go do something else, get coffee, at least. So that still works out. That's all I have. I can go through in more detail, or any questions? Questions?
How do you maintain like this was a hidden library 17 score that gets maintained across?
Oh, so how do we do the scores with the library stuff? Because yeah, so these tablets don't have a Wi-Fi, and that's on purpose to make them accessible to everybody. So what we just do is there's a reset. They have a reset somewhere. So when they check out, it's already all reset to the first exercise. When they complete the exercises, it shows them the report, and they can note it down somewhere offline if they want, or show it to their parents or their teacher if there's a teacher involved. But yeah, it doesn't stay after once the tablet resets. There's the home one, yeah. Home one is all the home and the school stuff is all the data is all stored in the cloud through Firebase. So they're actually, they're very different how they function. But we do show a report at the end of this because, we worked with some schools before, and even if they can't have the data, and we worked with some schools that work offline, they didn't have access to Wi-Fi, and they really, really still wanted the data. They could just note it down. They wanted to be able to, and they actually trained the kids to note it down themselves on cards and stuff. So at least they have some ability to do that. We still report the data, but no, we can't keep it because it has to go to the next person. But each lesson will individually show its report. In this case, you can't see a combined report. Nope. It's getting late, so it's good. All right.
Our next event is our DevFest Seattle. Many of you heard about the DevFest in Seattle? Okay. I just sent an email. We are mostly sold out. So you can still go on to that price. I have a few tickets left. And see you soon. Future meetups.